Hi, in this video I am going to discuss measure of central tendency. Now, in measure of central tendency I am going to discuss mean, median, mode, geometric mean, harmonic mean. Okay. Now in mean, to discuss the trimmed mean, weighted mean, types of data, different types of data on which you have to apply the measure of central tendency, mean, median and mode. Okay. Now, first of all, data generally there are two types: qualitative data and quantitative data. Now, qualitative data means where we cannot measure or where we cannot rank. For example, colors. Say colors red, green, blue. We cannot measure. Similarly, we cannot rank. Similarly, gender. Say male, female. We cannot measure. Similarly, religion, Hindu, Muslim, Christian, we cannot measure. Now, quantitative data means where we can measure or where we can rank. For example, height, say 164 centimeter or 5 feet. So these are the quantitative data. Similarly, weight, say 30 kilograms, where you can measure. Similarly, temperature, say 60 degrees Celsius. So all are quantitative data. More we can define. There are three types of data. Say raw data, and ungrouped frequency table, ungrouped frequency data, and grouped frequency data. Okay, so raw data, ungrouped frequency data, and grouped frequency data. Now, what is raw data? For example, we have a data, say student marks, say roll number and marks. Now, roll number, say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Say 13 students are there, and the marks are, say 98, 67, 77, 86, 45, 67, 86, 86, 32, 12, 43, 86, 58. Okay, now this is nothing but a raw data. Now anyhow we can summarize this particular data, and we can create ungrouped frequency table. We can create ungrouped frequency table. Okay, now to create ungrouped frequency table, so you just see how you can create it. So how many distinct values are there? So the distinct values are 12, 32, 43, 45, 58, 67, 77, 86 and 98. So how many 12 data are there? 1. So how many 12 data are there? 1. How many 32 are there? 1. So 1. How many 43 are there? 1. So there is one single 43. How many 45 is there? 1. So how many 45 is there? 1. How many 55, 58 is there? 1. Similarly, how many 67 are there? 2. So 67 So there is one here, it is 167 and another 67. How many 77 are there? 1. How many 86 are there? 4. And how many 90 are there? 1. So total it is 13. Okay. So this 13 is nothing but a summation of the frequency. Clear? Now this is a raw data. This is nothing but ungrouped frequency table. Okay. So here we can reduce few data. Okay, where you can save some memory space. Now further we can reduce the size of the data by creating group frequency table. Now to create group frequency table, so it divides into two parts, class and the frequency, which is nothing but a F. Say assume 0 to 20, 20 to 40, 40 to 60, 60 to 80, 80 to 100. So divide into class. Okay. Now how many data are there which are in between 0 to 20? It is 2. Okay. So, sorry, it is 1. So single 1, 12 is there. How many data are there which are 20 to 40? So 20 to 40, it is another 1. How many data are there which are 40 to 60? So 40 to 60, it is 3. Okay, 40 to 60, it is 3. How many data are there which are 60 to 80? So 60 to 80, it's another 3. How many data are there which are in between 80 to 100? It is 5. Okay, so this is nothing but our grouped frequency table data. Frequency table. This is ungrouped frequency table, and this is raw data. Okay, so if you create group frequency table, we can save space, memory space, but we are losing information. Clear? So, but if you are using computer, no need to use ungrouped and grouped data. You can use this particular raw data because the computer can handle this amount of data. Obviously, we are not talking about big data. Big data means it is a terabyte data. Clear? So if it is less than say 1 TB or say few GB, so easily we can handle. A computer can handle. So the question is how to create these classes. Okay, so classes should be clearly defined without any ambiguity, exhaustive, mutually exclusive and non-overlapping, equal weight, avoid open-end class. Open-end class means, so if you don't know the first class or the last class, it is called open-end class. Okay, number of classes neither too large or small. Okay, so generally we use 5 to 12 number of classes. Okay. Now there is one term that is called exclusive class. That is called exclusive class. So what is the meaning of that? Suppose one data is there, say 20. Okay, in raw data there is a 20. So 20 should be in which class? Class A or class B? Because 20 is somewhere here also and it is here also. Okay, so if you are using exhaustive class, so you just remember that upper limits are excluded from the respective classes. Okay, and are included in the immediate next class are known as exclusive class. So 20 should be in somewhere here. Okay, it is in group, in this particular group. So one question is there, where what about if 100 is there? So where you can store 100? Because after that there is no class. Clear? Okay. Now there is one term that is called histogram. Histogram. Now what is histogram? Now this is nothing but our data table. It is group data. Suppose you just create another group data, say classes and frequency, say 0 to 20, 20 to 40, 40 to 60, 60 to 80 and 80 to 100. Say frequencies are say 2, 4, 8, 3, 1. Okay, so we can draw a figure for this particular data. So you can draw a graph, say 0 to 20, 20 to 40, 40 to 60, 60 to 80, 80 to 100. Now 0 to 20, so we can divide this one, say 10, okay, 5, 4, 3, 2, 1, 6, 7, 8. So say 1, 2, 3, 4, 5, 6, 7, 8, 9, say 10. So 0 to 20, it is 2. 20 to 40, it is say 4. Okay, it is say 4. 40 to 60, 8. Okay. 40 to 60, it is 8. 60 to 80, it is 3. It is 3. 80 to 100, it is 1. So this is nothing but a pictorial representation of the group frequency table. So it is called histogram. Okay, so in histogram this is called, in class it is called lower bound, lower limit, and this is nothing but our upper limit. Okay, so it is lower limit and this is upper limit for the first class. Next, there is one term that is called frequency polygon. So what is frequency polygon? There is one term that is called frequency polygon. Okay, so if you identify the middle point of this particular bar, and if you connect this bar, we can get a figure which is called frequency polygon. Okay, so we can draw frequency polygon for the ungrouped frequency table and for the group frequency table. Clear? Next, we will talk about the measure of central tendency. So what is the meaning of measure of central tendency? So meaning of measure of central tendency is a value of the variable which is representative of the entire distribution. So representative of the entire distribution. Suppose this is a class 1 and say this another class 2. Now suppose we want to compare mathematics marks. So how you can compare mathematics marks? You just identify average mathematics marks from class 1, say A1, average mathematics marks from class 2, say A2. So A2 is suppose it's a mean. A1 is a mean and A2 is a mean. So A1 is the representative number of the class 1 and A2 is the representative number of the mathematics number of the class 2. Clear? So measure of central tendency, we can use mean, we can use median, we can use mean. So we'll see which one is in. We should the central tendency. The value should be easily defined. Clear? Easy to calculate, based on all observations, suitable for further mathematical treatment, little fluctuations on sampling, and not be affected much by extreme values. Okay, we'll discuss about all this more. Now, first of all, arithmetic mean. Okay, so first of all, measure of central tendency, we want to discuss arithmetic mean. What is arithmetic mean? Okay, now arithmetic mean means, suppose we have a data, say x1, x2 to xn, and suppose we want to calculate arithmetic mean, say x bar. The formula is x1 plus x2 plus xn divided by n. So we can represent like this way, summation of xi by n, where I is equal to 1 to n. Now arithmetic mode, sometimes you have you may find the mean is this one or s1. So we use mu if it is population data. If it is population data, we use mu to represent mean. We use x bar to represent the sample mean. Okay, so we use mu to represent the population mean and x bar to represent the sample mean. So mu, if it is population data, the formula is same. We'll discuss later about what is the population, what is the meaning of population, what is the meaning of sample. We'll talk about all these things. Now, if it is a frequency distribution is there, if it is a group data or frequency table ungroup data, the formula will be just same as that. The formula will be I is equal to 1 to n fi xi divided by capital N. So what is n? Capital N, capital is nothing but a summation of the frequency, where I is equal to 1 to n. Clear? Now, for example, say x, we have few data, say 1, 2, 5, 9. Okay, so what is the mean? So mean is nothing but a 1 plus 2 plus 5 plus 9 divided by 4, that is 17 by 4, that is 4.25. Okay, now how to calculate mean for the ungroup frequency table? Suppose the x values are 1, 3, 9 and 12, and frequencies are say 5, 2, 1, 3. Clear? So summation of the frequency is 5 plus 2 plus 1 plus 3. That means it is 11. Okay, 5 plus 3, 8, 11. Now, so first of all you have to calculate the fx. So fx is nothing but 5, 6, 9, 36, and the summation is 56. Okay, so and so the mean is summation of fi xi by n. So summation of fi xi is 56. Okay, and the capital N is 11. So it is something 5 point, say 56, 1 0 909, say 99. So okay, say 5.09. It is near like that. Okay, now in this way we can calculate the arithmetic mean for the ungrouped frequency table. Now similarly we can calculate ungrouped group frequency table, arithmetic mean for group data. Okay, group frequency table data. So suppose we have a data, say class frequency. Okay, say class is 0 to 20, 20 to 40, 40 to 60, 60 to 80, 80 to 100. So frequencies are say 2, 3, 4, 2, 1. So first of all we have to calculate the midpoint. First of all you have to calculate the midpoint. Okay, so what is how to calculate the midpoint? So midpoint formula x. So midpoint formula is nothing but a upper limit plus lower limit divided by 2. So this is nothing but our lower limit and upper limit. So 0 plus 20 by 2, it is 10. Okay, similarly upper limit plus lower limit by 2, 40 plus 20 by 2, it is 30, 60 plus 40 by 2, 50, 80 plus 60 by 2, 70, 100 by plus 80 by 2, it is 90. Okay, next, so the already you know the formula, it is fx by n. So this is nothing but f, this is nothing but f. So calculate the fx. So fx will be 20, 90, 200, 140 and 90. Clear? So by n, so summation of frequency, it is 12. Okay, so if you add all this, you will get the value 12, and summation of fx, it is nothing but our 540. So summation of fx is 540. So arithmetic mean is nothing but a summation of fx by n. So summation of fx means 540 plus 12, that means 45. Okay, so arithmetic mean is 45. Now we will see arithmetic mean using arbitrary point A. Arithmetic mean using arbitrary point A. So how to do this one? You just take same data 0 to 20, 20 to 40, 40 to 60, 60 to 80, 80 to 100. Okay, so the frequencies are 2, 3, 4, 2, 1. So the formula is, arithmetic mean using arbitrary point formula is mu is equal to A plus h by n summation of ft. Clear? So where A is a arbitrary point, h is the class interval, n is the summation of frequency, f is the frequency, and d is nothing but x minus a by h, where h is the class interval, a is the arbitrary point, x the values. So first of all we have to identify the x, which is nothing but the midpoint, So the midpoints, already you know how to calculate the midpoint, upper limit plus lower limit by 2. So the midpoints are, so 20 plus 0 by 2, it is so 20, 10, 30, 50, 70, 90. These are the midpoint. So first of all you have to identify the d value. Okay, so how to identify d? So d is nothing but a x minus a. So first of all we have to identify the a, arbitrary point a. So from the midpoint, so it's the mid from the this particular data midpoint, we identify a middle value, assume as an arbitrary point. So the middle value is 50, so assume 50 as an arbitrary point. So 50 as an arbitrary point, and h is a class interval. So upper limit minus lower limit is a class interval. So 60 by minus 40, it is 20, so it is 20. Okay, so d point will be x minus 10 by 2. So first 10 minus 50 by 40, so minus, so 10 minus 50 by 20 means minus 40 by 20, that means minus 2, so you just put minus 2 here. Similarly 30 minus 50 by 2, so 30 minus 50 minus 20 by 20, it is minus 1. Next point 50 minus 50 0, so it is 0. 70 minus 50, it is 20, 20 by 20, it is 1. Now 90 minus 50, it is 40, 40 by 20, it is 2. So we have identified the d. Next we have to identify the summation of fd. So f is this and this, so identify the fd. So we can calculate fd easily. So 2 minus 2, 4, 3 minus 1, it is minus 3, 4 minus 0, it is 0, 2 into 1, it is 2, 2 into 1, it is 2. So we have identified the fd. Now summation of the fd is nothing but minus 3. So minus 4, 0, 2, 2, summation of d is minus 3. Clear? So we have got all the values. Say, so mean is equal to a plus h by n summation of fd. So what is a? Is arbitrary point chosen 50. What is h? H is the class interval 20. What is n? N is the frequency, summation of the frequency, that is 12. So if you add all these value, we can get the summation of the frequency, which is nothing but a 12 into fd. Fd is nothing but minus 3. It is nothing but minus 3. So if you solve it, you can easily get 50 plus 20. So it is 15 minus okay, so it is minus 5, it is 45. Okay, so 45 is the mean. Basic properties. First one, algebraic sum of the deviation of a set of values from their arithmetic mean is 0. That means in property 1, say I is equal to n if by xi minus x bar it is 0. So algebraic sum of the deviation of a set of values from their arithmetic mean. So deviation, all the values deviation from the mean is 0. Or if it is ungrouped, we can write xi minus x bar equal to, so xi minus x bar 0. So this one is always mean. If it is, so we can write like this way: mean xi is always minimum if a is the mean. Clear? And the third is mean of the composite series. If xi bar, suppose mean of the composite series, if xi bar are the mean of k component series of sizes ni respectively, then the mean x bar of the composite series obtained on combining the component series is given by the formula. So the formula is very simple. So for the combined mean, formula is n1 x1 bar into x2 bar plus nk xk bar divided by n1 plus n2 dot nk. So the example is, suppose in a first series mean is something, number of data is this. In series 2 mean is x1 bar, number of data 2. So the combined mean is x1 bar into n1 plus x2 bar into n2 divided by n1 plus n2. Okay, so this is nothing but a combined mean. Merits and demerits. So arithmetic mean, it is rigidly defined, easy to understand and calculate, based upon all observations, amenable to algebraic treatment. Means further we can use mean value for the further treatment. Say we can calculate standard deviation, we can calculate coefficient of variance, okay, and so on. Variance we can calculate. Next, affected least by fluctuations of sampling. Okay, now demerits, limitations of arithmetic mean. Not for qualitative data. For example, say already you know what is qualitative data. Say we have 4 colors: red, blue, green, red, white. So how can you calculate mean for that? So you cannot calculate. Not handling missing data value properly. Suppose few values are missing. Suppose in this particular data, suppose one frequency is not there. So how to calculate the mean? We cannot calculate. If this particular data is missing, so we cannot calculate mean. Not for open-end class. Open-end class means suppose we do not have the first data or we do not have the last data. So it is open-end class, so we cannot calculate. So we cannot calculate the midpoint. So we cannot calculate arithmetic mean. For skewed values, arithmetic mean is not a suitable measure of location. So skewed values means we'll talk later in detail. Suppose the distribution is like that, or the distribution is like that. So these are the skewed data. So for this skewed data, we cannot calculate arithmetic mean properly. Finally, affected by extreme values. So this particular concept is very much important. Suppose we have a data, say 5, 5, 5, 55. Okay, and we have another data, say 25, 26, 24, 25. Now, what is the mean for that? So the mean for that is 25, and mean for the data 2, it is same 25, but the distribution are different. Now for the data 1, we have one extreme value. So 85 is the extreme value. So then what is extreme value? Extreme value is a value which is far away from the rest of the data. So it is a value which is far away from the extreme rest of the data. Okay, so 85 is the extreme value. So this for this particular 85, the mean value is much more high. Okay, so if extreme values are there, we should not use arithmetic mean. So there is one concept that is called trimmed mean. Trimmed mean. In trimmed mean, we suppose we have used trimmed mean for 1% data. So if the data is, say, a few data are there, so and you arrange it, you sort it, so we reduce lowest 1% and remove highest 1%, and we just calculate arithmetic mean for this particular data. Okay, so trimmed mean means, suppose we want to identify calculate 1% trimmed mean. So 1% lowest data, 1% maximum data we removed, and we calculate arithmetic mean for the rest of the data. So if you use trimmed mean, so 5, 5, 5, 85, we can remove the lowest data, one extreme data. So if you calculate the mean, so the mean value will be 5. Okay, so if extreme values are there, we should not use arithmetic mean, we may use trimmed mean.